Okay, I'm gonna do a couple announcements and introduce.
Hey everyone. Thank you for coming today. Before Deron gets started, I have an ask and a give. So if you're looking for a binder, we brought a box of binders. Let me know, get them before they go to surplus. The ask is we're looking for a chair on wheels that can be at least 22 inches from the floor. If you have an extra chair somewhere that you can give to us at Earl, we really appreciate it. We've tried 5 today and we can't find one that works. So anyway, if you have something, please let me know. Okay, with that, those were the announcements. And then I'm gonna hand it off to Deron.
I think I've met most of you, but for those I haven't, I'm Deron Zierer. I started with KGS in May, working with Marty and Steve on the Orphaned oil and gas well project. And we've been working closely with the Kentucky Department of Oil and Gas and the Well Done Foundation in efforts to estimate measurements from these orphaned oil and gas wells. Yeah. A little bit of background information first. Orphaned oil and gas wells are wells that are deemed to have no responsible owner. Most of the time that's due to parties that owned the well or drilled the well going financially insolvent. And these wells are obviously local factors in producing harm to groundwater, soil, local air quality. This is a well in McLean County that's in an actively farmed cornfield that's basically an oil slick. This is a well in Breathitt County, right next to Lost Creek, that was under 2 to 5 feet of water at the time of the 2022 floods. This well, as we progress through this presentation, this is the well that we measured via bag sample because we couldn't figure out another safe way to measure this well for the emissions it was putting off because of how complex this one was. Then on a global scale, methane is generally bad for all of us trying to exist on this planet. Since the industrial age started, methane has increased by 165%, mostly due to human actions. And this is driving warming and climate change. Nationwide, there's 3.7 million orphaned oil and gas wells. In Kentucky, there's 14,000 known orphaned wells. This makes even the idea of trying to put a number behind the emissions that these wells are producing very difficult, just because of the sheer number of wells present throughout the country in the state. That's why the EPA has such a wide uncertainty in how many metric million tons they produce in methane per year. So in order to understand why these wells are leaking, we have to understand a little bit about how we get the hydrocarbons up from the reservoirs in the first place. So most oil reservoirs in Kentucky require mechanical lift to get oil to the surface. Sucker rods drive downhole pump to lift oil, gas, and brine to the surface. This is a lot of moving parts that break while they're moving and also after they've stopped moving for many years, which is why we have problems with orphan wells now that have set with all the parts in place for 50 or more years, but are leaking, have continued to leak, or could have just recently began leaking, and we have no idea because no one else has observed them. To add on to that, just through the casing infrastructure itself, there are many avenues through which the hydrocarbons can leak. That's in the surrounding soil, surrounding aquifers, whether they be fresh or saline. And then, of course, out the top into the atmosphere. This is where the surface infrastructure present plays a big role in the potential emissions of these wells. So we've observed that intact wellheads seem to be maintaining some back pressure on the reservoir. And that's because of reduced atmospheric intrusion into the well. These wells have a greater future for emissions, but we don't know exactly when they started emitting because of the lack of observation of these wells. So they could have also always had this back pressure on the well, enabling for these emissions to be taking place steadily throughout the years. Open wellheads, on the other hand, seem to be lower emitters for the most part. And that's because an almost balance has taken place between the atmosphere and the reservoir. So getting into the field work, the first thing we do when we approach a well is a pre-test screening. That's a Lycor gas analyzer. It detects methane down to a ppb, and we scan the well, trying to find any ports or valves or joints where methane is leaking. For this particular well that was in Warren County, we detected greater than 100 parts per million leaking out of the valve. But this is an old well, so you can probably tell by the kind of odd looking infrastructure of it. So there is no supporting information on it at all. We don't even know which year it was drilled, just that it was old, pre-law well. But on wells like that, we can potentially do a direct connect because there is infrastructure in place. So when we do a direct connect measurement, we attach the vent buster in addition to normally some piping that we bring out into the field onto the well itself, enabling us to get a lower end estimate of emissions from that port. We choose that port based off of the pre-screening methane detects. It's not always that simple though, since these wells have so many moving parts. Sometimes if you can manage it, it's nice to measure two different leakage pathways, which is what we did with this well. Attaching one to the piping off of the rods and one to the piping off of the annulus. There are also situations where you don't have any choice but to do some form of direct connect measurement. So this well, the primary leakage was actually from cracks within the wellhead, but because of the rod sticking 6 to 7 feet up in the air, there was no way in the flow line running off of the well, there was no way to get a chamber over it to capture all the emissions coming from this well. So it's really important to keep in mind that for some of these direct connect measurements, it really is a lower end estimate of what the potential methane emissions would be. The other measurement that we've primarily used is dynamic chamber measurement. And this is done in situations where only the casing is at the surface or where the wellhead infrastructure is so damaged that there is no way to directly go into it with the flow meter. This method produces a couple of challenges. These fangs are heavy. You have to bring them up the hill. You have to walk through the woods with them. You have to bury them a little bit to make sure the seal is tight and that no potential emissions are escaping from the underside of it. The upsides is that it does capture the total leakage from within the well because you're containing that entire system. But on most of these wells that are completely open to the atmosphere, it doesn't seem like they're really producing that much. So it can take a long time for sufficient pressure to build up within the chamber that a significant flow is even registered within it. And then this is just another thing that we've struggled with on this project is the rapid pace at which wells have been plugged. So this is a direct connect test that we did in Warren County, and set up right next to it is the pluggers who were moving in right after us to plug this well as soon as we were done with it. Of course, after a well is plugged, you have to go back and make sure they did a good job. So what we have here is a well in Lee County before and after the plugging process. And what we have done so far is we've revisited these wells and done methane flux measurements on them to see if they were plugged properly and see if there is any residual methane leaking into the atmosphere. Most of the soils in Kentucky absorb methane. So this flux chamber connected to the light core is able to see what that flux is. And if you have a negative flux, then the well probably isn't leaking. They don't always look this pretty though. So far, we've already came up to one where the plug job has seemed to partially fail. And we were getting methane detects off of this. So it's kind of hard to see because it was covered by leaf litter, but that's the well. That's the casing of the well. And that's also the casing of the well after plugging has occurred. So all just fell in. Water was down in the hull. I don't know if that water was brines or if it was water from rain events. But we were definitely getting a methane detect off of it, which indicates that these things will remain active if they find a way to get to the surface. Along with the problem of there being 14,000 plus wells, there has to be a way to categorize these to try to get a handle on what their emissions would be and to try to find the bad emitters in the mix. So what we have done initially is divide these wells based off of their producing hydrocarbon in the formation that is producing, the age of the formation that is producing the hydrocarbon. And starting in February of this year and finishing up in the end of August, we ran 50 tests with well done. We have sufficient data from 47 of those tests. The other 3 were interrupted by cow tippings or cable failures or rain events.
I'm gonna tell us that story later.
I could. So the way that we get a methane emission estimate from these tests is the flow meter records actual flow of volume through the device. It doesn't detect methane, but we take a sample from the chamber or from the well at the end of the test and use the percentage of methane found in that in this formula to estimate how many grams of methane are being emitted. So subgrouping of the wells, I think, has helped us a lot. If in nothing else, just in trying to wrap your head around, okay, how do we approach this? Do we just go and look at all of them, or do we look at certain populations that we can define? And it also helps because each of the regions in Kentucky are a little bit different. So having these subgroups can help us get a better idea about what was going on in all of them. So this first graph is on a logarithmic scale. And I have it titled infrastructure emissions. That's because if you have a direct connect, you can infer that there was enough infrastructure in place that we could directly connect to that wellhead infrastructure without worrying about anything occurring. The bag sample is from that well off of Lost Creek that I showed, where there wasn't really a safe way to do a direct connect, and there was not a safe way to do a chamber measurement on it either. So we get an estimate based off of how long it took to fill up a static bag from a valve. The chamber measurements are open wells. And looking at this, you would think, wow, the direct connects, they're the real problems. But if you go on to look at this graph, which also a logarithmic scale, where we have it split up based off of geologic age, it's a very different graph, where most of the emissions are occurring within 3 different wells. That's 9 subgroups that we've defined so far based off of geologic age. And this is what I found really interesting. If you take those 2 groups and put those categories together, it creates a lot clearer picture about what the geologic age of the reservoir and thus the behavior of that specific reservoir and the wellhead infrastructure have on the potential of emissions. So the 2 highest emitters that we have are those Mississippian gas wells that are direct connects. The other Mississippian gas well that we measured wasn't emitting any methane, but it was a chamber connection, so it had already reached equilibrium with the atmosphere and was no longer emitting. But these direct connect wells in which there's still pressure on the reservoir, they just seem to be shooting methane out at a pretty steady clip, especially when compared to all of the other wells that we've measured so far. The Silurian Devonian oil, those 15 wells, 14 of those are emitting less than a gram an hour. There's 1 well that's an outlier in that group. Then it rapidly drops off from there. So from this first round of field work that we've completed, it seems that wellheads with an infrastructure in place, both oil and gas wells seem to have an instantly higher chance of being emitters. Then compared to that, gas wells have a higher tendency to be emitters as well, with that being our highest emitter today. Oil wells, most of them have not been emitting anything, but most of those have also been wells in which there was chamber measurements. For the low emitters, methane emissions likely begin attuned to the atmospheric infiltration. The idea behind that is that for these open casing wells, like I said before, they've become equilibrialized with the atmosphere, even though they do have, most of them we've observed that there's a liquid within them, whether that liquid be water or oil, depends on the well. But most of them you don't even see bubbling happening within the well. A problem with this is that it's impossible to predict the wellhead infrastructure before you actually go up to the well. So if we do find that it's more dependent on infrastructure than it is on the producing reservoir, it's going to become increasingly difficult to try to summarize the most efficient way to target the higher emitters, because you would have to manually visit every well to see the condition that they're in. And looking ahead, gas wells appear to make up about 10% of the orphaned oil and gas well population in Kentucky. And the annual emissions we've measured is equal to 11 tons of CH4 a year. Yeah, it's been exciting times in the field, compiling all this data. That's all that I got.
Any questions?
Yeah, you were referring to many of these problem wells with pre-law wells. Could you expand more on what and when that law that went into effect that was enacted to prevent this kind of thing?
So a lot of, if I said that, I misspoke. A lot of the wells that we are having problems with, they aren't necessarily pre-law wells. A lot of the wells that are burdening us with this system we're trying to create in sorting the wells that are giving us problems are pre-law wells. And I don't know when that law came into effect. Late 50s. And that's just because there's very poor record keeping pre that. So you don't know what reservoir is being produced from or how deep the hole was dug, or there's not even driller's notes for many of them. Yep.
Tracking environment or pressure changes.
So the vent buster tracks changes in pressure that it measures, but we haven't independently done that yet. I think that changes in you can observe changes in barometric pressure based off of our measurements though, because there's a distinct day and night difference. So what we've observed so far is kind of counterintuitive. So at night, flow decreases, and at day, flow seems to generally be higher than it is at night. And with the relation to barometric pressure, you would think that that would be opposite.
Did you say, I just didn't hear, did you say it decreases at night?
Yeah.
The testing equipment, you say it's got infrastructure, is it like an airtight thing that you test these with? And then on the wells that are open to the atmosphere, what do you do? How do you test those?
So that's the direct connect versus chamber measurement. So the vent buster, find a picture of it. So this is the vent buster that's attached to the top of this chamber. It's what actually records the flow. When we do a direct connection, it's airtight for our purposes because we use piping to directly thread into everything and then attach the vent buster to that piping. But for a chamber measurement, it's as airtight as burying the chamber a couple of inches deep and allowing whatever is emitting from the well to travel into it and then up and out of the chamber.
Those well heads are usually open to the atmosphere, is that right?
Yep.
Okay. Okay, alright. Alright.
Anything else? I have a question. Is there any sort of effort being put to try to figure out the total number of wells? Like, I understand that we know of about 14,000 of them. Is there any sort of like citizen scientists?
Carrie's
Or
put a lot of
state
work into
or-
that. And just trying to sift through old records and estimate. Carrie would be the person to ask about that.
Is there any mechanism through the state to report a well on your property?
So there is on Kentucky Department of Oil and Gas's website, you can report a well that you find. They have a form that you can fill out. And then I'm sure that if you went down to City Hall or something, wherever you live, that you could badger someone enough and they give you the local oil and gas inspector's number. You can call them. But I mean, some of the wells, a well in Wolf County, actually, it didn't have a permit number before we got to it. People knew it was there. It just was off the record, off the system. I don't know if that's because it was a pre-law well or if it was because it was a wildcat well, but it didn't exist in anyone's record book until we went and measured it.
About the parking lot, the dog, everyone else is doing it.
Yeah.
They're worried about it.
Can you characterize the success rate of plugging old wells? I mean, pre-law or any others that you've looked at?
Well, that I've only been to like maybe 6 or 7 wells post plugging at this point. So my numbers, I hope, skewed towards the negative because that means that 1 out of 6 that I've been to has been a failed plug job. But the state did just recently, well, they added like 20 more wells, but they're finishing up plugging 640 wells throughout the state. And the next big slug of outfield work is going to be going to some of those and seeing what their current conditions are. Now, as for wells before this that were plugged, I have no idea because I don't think that any entity has ever required an inspection post plugging before the bipartisan infrastructure law came into place. Yep.
You showed the one picture of the one that was like leaking visibly like liquid out into the at the site. Is that an anomaly? Are they usually just leaking gases or?
That's the worst one that I've seen.
Okay.
A lot of the wells, I have been to, not a lot. I have been to a couple of wells where the immediate soil surrounding it will have sows of oil on it that you can guess, okay, that obviously came out of the well that's present here. But no, this is an outlier in how bad it is. And then to make it worse, this tree line, this tree line is the Green River. So it's right in the floodplain of the Green River.
Is the plugging protocol different for something that's liquid?
I think just in safety concerns. Because, I don't know what would happen if they took the sockets off of that. And then the same thing goes for this one. Like this one, when we did the bag sample, we held the bag over top of this part of the well. But it's leaking methane on virtually every joint you can imagine within that infrastructure. There's gas hissing out of it. So whenever there's something like that, the danger factor just goes way up. And safety becomes more of a concern than anything else.
So for that one, that was the bag test. You have leakage below where you're actually collecting, and then wasn't that one of your highest?
Yep.
Yeah,
And so that's a lower end estimate as well.
yeah.
It's fair to say that if these wells were sitting in Chevy Chase, they would have plugged.
Yeah, that's. Or if they were right outside of Lexington, they would have been plugged.
Yeah, I was just curious, how do you know which one is safe to attach your flow meter to? Like,
So-
you gotta take something off and then thread it back on, or, you know?
No, we never remove anything. So, yeah, you can. On these ones like this that are trying to explode, you can hear the hissing. And when we go out in the field, we also wear our protective. So we have a H2S sensor that we wear, and we also have a 4-gas, which detects the explosive limit of materials, the lower explosive limit. So we do both of those, have those on us at all times. Yep. So it's not a great picture, but I do have that one. So this is like a mobile drill rig on steroids. They rip up all of the casing and the rods and the tubing, and then they fill it back in with concrete. That's the short and simple of how they do it.
So basically, first thing they'll do is lead off, but
Yeah,
there's a lot of pressure on well, don't have a water supply source there, and water down the hole. And, once that's done, they have control of the well. Then they'll start the process, and you'll actually have an on-site, cement mixer. They're right there and it's on the hole. And, inspector has to be present when that happens, so they check the cement consistency, so they send it down the hole, or to the bottom, they usually done correctly, they should stand at a certain distance, put in the plug, and above that plug, and hang on to that well, and happen several times over. Until they get all the way to the surface, and, that's cemented for several days, and then, it's a good job. They'll come back in and, actually cut the well off with the below the surface. So there's no surface manifestation on the well bed. They do that in farm fields, especially those farmers that have plows and things like that are, tearing up the plow on the well head before. So
How did the plugging job that failed fail? I've never heard of a plugging job failing before.
so when we were out on that site, that one was kind of an anomaly to begin with because the local oil and gas inspector said that when they were plugging the well, they found a big wooden berm cylinder type thing around the well. I don't know why that was there. I don't know if it was open pit dug when it was initially
I heard
drilled.
stories of wooden casing back in the day.
Yeah, so
All about law.
Yeah, that was a big wood surface, casing, extended about 2 feet from the immediate well that they put in place.
So yeah, that it's kind of hard to see, but there is there's the obvious hole and then there's a depression as well around that hole. And we think that that's where the wooden casing was at, and the plugging crew probably just wasn't used to dealing with that and led to problems, and you have a failed plug job.
What do you do when it fails?
Come back and try again.
Did they reflect this one?
I don't know if they have yet. So we went to that one in July. I think like at the end of July. So they could have gone back and plugged it by now again, but we haven't been back out there to see it.
They will leave it not. Or-
Yeah.
Yeah.
Report. So the other thing to point out that well, so in the left photo, you're looking at what's called Fixer Road. So we're only 20 feet off the road there. And, you notice in a somewhat rural area, that was actually a major, quote unquote, major road, in the area. So there's traffic on there all the people going in to have cabins. There's actually a resort there, in the area. Happy Valley Resort.
I think that's it.
The Red River Board Climbers Coalition and Quad, one of the projects there, so. This area has a lot of recreational and. It just kind of gives you another sense of how close and well. Everyday activity.
That well is within a mile of that well. Probably a lot closer than that, but definitely within a mile of each other.
Thank you. That was great. Um,